Hello friends, in this video we will learn about the equilibrium. So what happens is that when the resultant of all the forces acting on a body is zero, the resultant is zero, okay, let's say resultant by R. If this is zero, in that case the body is said to be in equilibrium, which means that, so let us say that we got a body over here and this body is on rest, okay. So after certain time you apply certain load in this direction, certain load in this direction, certain load in this direction, and certain load in this direction as well. Even after applying these F1, let's say this is F2, let's say this is F3, and let's say this is F4. Even after applying these four loads, the body still doesn't move. So if this happens, we say that the body is in equilibrium, okay. So I'm just too lazy to write this twice. So this can be simply approximated by an example. So if this is your body and you're applying a load in this direction of 30 kilonewton, so if you are just applying the load of 30 kilonewton in this direction, the body will move here. However, if your friend pulls the body from here with the same force of 30 kilonewton, then the body will not move, so it will still remain in rest. So now we say that the body is in equilibrium. So this is one condition of equilibrium. So another condition is that we know the Newton's second law of motion, which is also the derivation from the first law of motion. So Newton's second law, it says that the resultant of the force, or the summation of the force on a body, that is F, is equal to mass times the acceleration. So this force is not the force acting on a body. So this is the force that is unbalanced, which means that, so if this is your body and you're applying a load of 20 kilonewton in this direction and you're applying the load of 10 kilonewton in this direction, now in this equation F is equal to ma. F is not 20, F is not 10, so F is 20 minus 10, because the unbalanced force in this condition is 20 minus 10 is equal to 10 kilonewton, okay. So this unbalanced force is also the resultant force. So we say that in equilibrium this resultant force is equal to 0, okay. So as I've already told you, the resultant force is 0 for the body to be in equilibrium, not the force but the resultant force. So this is 0, which is equal to m times a. If a body exists in this universe, it cannot have mass is equal to 0. Definitely a must be equal to 0 for this equation to be true. If a is equal to 0, which means that we have got a velocity is constant. Which means that if we got a body, so now the body has got tires here because it is moving, and the body is moving with a constant velocity under the action of many forces. This body is acted upon by forces in various directions, and even after applying these many forces, F1, F2, F3, and these all forces, if still the body is moving with the constant velocity, then we say that the body is in equilibrium. So in a 2D plane, what happens is that in a 2D plane we saw the component of the forces. So let's say that, so this is our x direction, and this is our y direction, and this is our body, right? Okay, this is x direction, this is y direction. Now let's say that we got a force acting in this direction. let's say this is force F1. So we know this angle theta 1. Now you can find the force in the x direction, you can find the force in the y direction. Similarly, we got the force in this direction. Let's say this is force F2. So this is our negative x, so minus x, I'll say that. So you have got the force F2, you know this angle theta 2, right? You can find the components, right? Similarly, you got the force in this direction. Let's say this is F3 and this is angle theta 3. You can find the component in the x direction, you can find the component in the negative y direction. Okay, and also let's say that you got the force F4. So now I'll just draw the force F4 here, and the angle is theta 4. Okay, so for this body to be in equilibrium, there are two conditions that this body will have to meet, and that is summation of the forces in the x direction. So that is summation fx. This must be equal to 0, which means that you find f1x, you add it with f2x, you add it with f3x, and you add f4x. So this all summation, this must be equal to 0. Also the summation of the forces in the y direction, it must also be equal to 0. So if these two conditions are met, we say that this body is in equilibrium. So in a 2D plane, this holds true. In a 3D plane, what happens is that, so in a 3D plane, so this is our x direction, this is our y direction, let's say that, and this is our z direction. So this is x, this is y, and this is z. So whenever we have got the force in the 3D plane, so let's say that this is our force F, it will have the component in the x direction, it will have the component in the y direction, similarly it will have the component in the z direction as well. Okay, for any body to be in equilibrium, summation of fx must be equal to 0, summation of fy must be equal to 0, and summation of one more coordinate, that is z, must be equal to 0.